Hello, everyone. My name's Joe Robert, and I'm a technical marketer at Epic. I've been using the engine for quite a while. Prior to that, I was mainly on the film and TV side on Maya. I worked at Autodesk for a very long time. So I think I see some familiar faces out there. Good to see y'all. Thanks for coming. Today's class is an introductory to PCG, so it's going to be covering kind of basic core concepts. We're not going to be going down too deep into it. There's several other PCG classes that are being given at Unreal Fest this year, so if you want to get into something a bit deeper, I definitely recommend after this one maybe trying to see if you can get on your schedule some of the other classes that are a bit more in depth. But what we will be doing is hopefully giving you guys an understanding of how this works, kind of coming from the persona of a DCC artist. So, you know, coming out of Houdini, or maybe XGen in Maya, or Bifrost, even Railclone in Max, even kind of some of the geometry nodes in Blender have very similar kind of ideas behind them. You know, at the end of the day, this is a procedural content generation tool. What we're really doing is we're just instancing stuff. Like, that's at the core of what we're doing. Is we're essentially sampling data, we're taking points in space, we're filtering those and playing around with them, and then we're gonna spawn things from them. So that's kind of the approach of what I'm gonna be showing here is, you know, building up some basic tools that give you sort of that same functionality that you might be used to coming from a traditional DCC background. So we're gonna start off today by building some roof tiles on this, and then we're gonna get a bit more complicated and start building out that fence. So let's go ahead and jump over into Unreal, and we'll start going through some basic concepts on how you can spawn some geometry based off of other meshes and things like that. That's really what we wanna get through in this very first section.
All right, so the first thing that you're going to want to do if you're working with PCG in your own projects is make sure the plugins are turned on. So go to Settings, Plugins, search for PCG, and you can see in my project, I already have Procedural Content Generation Framework turned on, as well as the PCG Geometry Script Interop. And Geometry Script and PCG can work together to do some crazy powerful things. In my presentation, a couple of the nodes that I'll be using utilize this Geometry Script Interop to work. They actually wouldn't even show up if this plugin wasn't turned on. So I'll make sure to identify those when I'm working with them, just so you're aware which ones they are. All right, so with that said, what we want to do is we want to create a new roof on this treehouse that's going to be a tile roof based on a Quixel asset that I've already downloaded with Quixel Bridge. It's worth noting that all of the geometry that makes up this treehouse are Quixel assets. They're just Quixel assets that I downloaded and then kit bashed together using some of the modeling tools inside of Unreal. It's also worth noting that the background environment is based off of the Electric Dreams sample project. And Electric Dreams is an amazing project if you want to learn more about some of the more advanced topics in the procedural content generation framework workflow. It's a really, really deep project that you can dive into that goes well beyond what we're going to be covering today. So to get started, let's go ahead and turn off that wooden roof, and I'm going to turn on these four static meshes that are going to assist us in the creation of our PCG graph that's going to make our tile roof. What we want to do is we want to sample points on this geometry, this roof geometry that we just turned on, and then instance to those sampled points the tile, the roofing tile from that Quixel asset that we downloaded already. So to make it a bit easier to work with in the PCG graph, what I'm going to do is I'm going to actually merge these four pieces of geometry together into a single static mesh using the modeling tool. So if we click on modeling and go to Xform, click on merge, and then click the accept button, you can see in the outliner we now have a combined static mesh that makes up all of those roofing pieces. Now, the next thing that I want to do while I have these modeling tools up is I actually want to add a deformation onto this roof to give this ridge line a little bit of sway or bow, so that it looks more similar to what we had with that wooden roof. So we'll click on Deform, and we'll just add a lattice onto that piece of geometry, kind of go in here and grab this control point on that lattice and drop it down. Now you can see that it's using a linear interpolation between these 2 points. That doesn't look that great, so we'll switch that over to cubic, and it'll kind of average that across all the polygons that make up this roof to have its kind of nice, smooth, swaying roof line across that ridge of the roof. So we now have a single piece of geometry that is ready to go and use in our PCG graph. So let's go ahead and start creating that PCG graph now. By jumping into the content browser and going down into a folder that I've already created. And what we want to do to create the graph is just right click in the content browser, go to PCG graph, and give this a name that's a little bit more meaningful. So we'll call it PCG underscore roof. Ooh, I'm spelling things completely wrong today. Roof and Unreal Fest. All right, cool. So we've got this graph. It lives in our project, but it hasn't been added to our level. So for it to show up in the level, we need to add it to it. So we'll just drag and drop that into the level. You can see it's now in the outliner. And then the next thing we can do is go back into the content browser and double click on that graph to open up its editor and begin creating some nodes that are going to ultimately create a tiled roof on our little treehouse. So this is the PCG graph window. I'll give you a quick overview of it now. So the middle graph window is pretty similar to the blueprint graph or even the material editor, similar to both of those. Details panel is just like all the details panels that live inside of Unreal. I'm sure you've used that a ton. On the left-hand side are all the nodes that you can use to create your PCG graph logic. So sampling nodes, filtering nodes, math nodes, all kinds of nodes that you can use to create crazy cool PCG graphs. If you right click inside of the actual graph window, you get a pop-up that also has all of the nodes that you can use to create the logic. So you don't really have to have this left-hand panel turned on if you don't want it, because you can get the information right here by right-clicking directly in the graph window. Then on the bottom is the window for inspecting the metadata that flows throughout the graph. So as you click on different nodes, you can basically enable and disable the ability to see the different data that exists in your graph. And that data is very useful. We'll use this window a bit more in depth as we start to build up some more complex graphs. So more of that to come throughout the presentation. So with that said, let's go ahead and start building up a graph that's going to give us roofing tiles on our little treehouse. So the first thing that we want to do is we want to go ahead and sample this piece of geometry to create some points. So to do that, we're going to right click and we're going to do a mesh sampler. So the mesh sampler is one of the nodes that actually uses geometry script. So if you didn't have the PCG geometry script interrupt plugin turned on, that node wouldn't show up, and that's why. So if for some reason you right click and it's not there, turn the plugin on and you'll be all set. And you actually use the mesh sampler a lot. So, just make sure that plugin's turned on. So we drop that guy down and you can see that it has an error. The reason it has an error is because we haven't added a static mesh yet. So let's go ahead and add in that static mesh that we just made, which is the combined static mesh. And as soon as we do that, you can see here it is and everything's happy. The sampler is no longer complaining. So now we've got this sampler trying to sample 1 point per triangle. Great. What do we want to do with that? Well, we want to take that sampled information and we want to spawn a static mesh. So if we drag off of the out pen and search for static mesh spawner, you can see we've now got these two nodes wired together. Let's just highlight those guys and hit Q to line them up. And what static mesh do we want to spawn? Well, we want to spawn a tile mesh, and there's a few different ways this static mesh spawner can work. We're going to leave it on the default, which is weighted, static mesh selected weighted. What weighted means is you can add multiple mesh entries and you can adjust and bias how much any static mesh is going to be represented based on the weighting that you've assigned. Now for this, we're only using one roofing tile. So we're just going to click the mesh button one time and add one array element. So in that array element, we're going to go and add in the mesh that we want to instance on that sampled data, which is going to be a tile that I got from Quixel. So it's just a simple roofing tile. So cool, we've now got a sampler. We're spawning static meshes off of that data that we've sampled, and you look in your viewport and nothing happened. Actually, something happened, but you don't see it. The reason you don't see it is because it's over here to the side, and you might be thinking, well, heck, why is it over there to the side? The reason it's over there is because this is actually kind of where the origin is. If you look at the piece of geometry that we're sampling, it's always going to be using the static mesh. So this static mesh, this piece of geometry it's got an offset in it, right? Like we've pushed that guy way over. My treehouse is not at the origin. So what does that mean? Well, it means like if we go back to this mesh and we drop it in our level and we zero out its transform, you can see that's that mesh at the origin. And then you can see, hey, guess what? This spawner, this sampler happens at the origin, and then the stuff that's being spawned is happening at the origin. So it's not where we want it in world space, and that's okay for now. Like, let's just get the roof looking cool, and then we'll sort out offsetting it and aligning it with the actual piece of geometry a little bit later. So how do you change the way this roof looks? Because right now, it's not looking good. Like, I have these tiles, but they're too small. They're going the wrong direction. They're actually tiled in a weird way. So the first thing I'm going to do is I'm going to go back to my mesh sampler. And instead of having it sample once per triangle, I'm going to switch it to sample 1 point per vertex. So that's putting out points for every vertex now. Great. Looks great. The problem is it's going the wrong direction and they're too small. So what we want to do is we want to modify these points that we've generated with the sampler before they get to the static mesh spawner. So how are we going to do that? Well, we're going to modify them with a transform point. So if you search for TR, and this is a great tip for searching anywhere in Unreal, you don't have to write out transform. I'm really bad at spelling. That would be hard for me. So if I do TR space PO, it gives me the first word and then the space and then the second word. So just 2 letters, space, 2 letters, and you could do that a third time, a fourth time, it doesn't matter. So now we got the transform points. Great, let's go ahead and break this connection and wire those guys up. Looking good. Now, we have a transform points in here, but we actually haven't transformed it in any way. So the first thing that I'm going to do is I'm going to spin these guys around and I'm going to go in the correct direction. So we're going to do -90 and -90. And you know what? I actually want to have a little bit of variation on this. So we'll do like -88 and then like -93 so that they have a little bit of wobble on them. You know, there's just like 5 degrees about of like just randomness rotating those guys around. And then the next thing we're going to do is we're going to make them big. We'll make them like 5 by 5. So, okay, cool. They're starting to look a little bit more like a roof. Now, they're a little bit long for this kind of stylized roof that we're doing here. So what I'm going to do is I'm going to turn off the lock and come down here and turn off uniform scale, and we'll make this like 2.7 by like 3. So again, there's a little bit of randomness. Some of them are a little bit longer than others. You know, we could even do 2.6 or something like that. So that starts to look a little bit better. Now, the next thing that I want to do is I want to translate these guys down a little bit. So I'm going to do -28 on that. Oops, that's rotate. That's not what I want to do. Let's zero that guy out. So a lot of experimenting when you're playing around with this. We want to go to offset. So we want to do -25 on that guy, and then maybe a little bit more like -28 just to kind of offset those so that they're starting to look a little bit better. And then I also, if you look at this right here, you can see that, you know, they're not very high. That roof that they're spawned off of is kind of coming through. So I want to pull them out off the top of that roof a little bit. So and you can see it here on the back sides too. So if we do something like 10 on that guy and maybe like 18 on this guy, we're going to kind of pull them out so that they're sitting up a little bit higher, and that starts to look pretty good. Might be a little bit too far, maybe something like 15 on that. And then I can give it all a little bit more of random rotation. So we'll just do like -2, I don't know, to 4, 5, -3 to 5. So, you know, they're just kind of randomly broken up with a little bit of change in rotation, a little bit of change in length, a little bit of change in the transform, and it gives us this sort of really nice tile roof that's got this sort of fun little look to it. And you know, maybe some of these guys. Let's see if we do something like 12 and like 4 on that. That looks a little bit better. Yeah, so that's kind of fun. So like I said before, this is at the origin. My treehouse is over here. I want that roof to align with this piece of geometry. So how do you do that? Well, there is a node in here called copy points, and copy points is a workhorse inside of PCG. You're going to use it a lot. So what we want to do is we want to copy the points and combine them together of these two meshes. So if we take our transform points, which has got them looking good, and we drag out and we do a copy points, that's going to give us our source. Now, the target that we want is going to be this piece of geometry. So to get the position of that piece of geometry, we're going to use another node called getActorData. So getActorData is interesting. Like there's lots of different things you can do with getActorData. So what we're going to do is, instead of having it filter itself, we're going to tell it to look at all the world actors. So then it's going to want a tag, and the tag that we're going to look for is DTO. Ooh, got to spell correctly. So let's put DTO in there. Let's take this piece of geometry. Let's search for tag down here. And on our actor tag, I'm going to add a new one, and we're going to call it DTO. So that's cool. We can take that and throw that in there. And let's just break that, do that. Let's align this stuff up so that it looks kind of nice. Well, kind of nice. It's not perfect, but it's okay. Now, I did that. What happened? You don't see anything. It's actually sitting up here. And wow, that's a lot of roof tiles. The reason that it's so many roof tiles is what this getActor is sampling is not what we want. We don't want the mode to be parse actor components. We want it to be the single point. It's transform. So as soon as we switch that to single point, just like that, our roof is now exactly where we want it. So let's go ahead and just close that down and check out our cool little roof that we just made. So that is the basics. That's about as simple as it gets. But we're doing something kind of fun. We're doing something very architectural with the procedural content tool, which I think is super fun.
So the next thing that we're going to do is we're going to go ahead and we're going to create a spline-based tool that allows us to scatter things down a spline. We're going to build a fence, and then we're going to build a more complex fence. So let's go ahead and jump back into Unreal.
And create that simple spline-based tool. So step one is to create a blueprint. And this blueprint is going to be an actor blueprint. We'll give it a name, BP_fence UF. And if we double click on that, there's a few things we want to set up. So we don't want to have start on tick enabled, and we need to add two components to this. The first component is going to be the spline. This is going to let us generate a curve that's going to define where our fence exists and the shape of it. Pretty straightforward. And you can see that curve just showed up in the viewport there. The next component that we want to add is actually a PCG component. So we'll search for PCG, and we'll add that PCG component into the blueprint. And if we highlight the PCG component and go down to the details panel, you can see that it's expecting a PCG graph, right? We haven't made a PCG graph for this fence yet, so let's go ahead and do that now. We'll hit the content browser one more time, right click, and create a new PCG graph. That's going to be the PCG graph for our fence. So we'll call it fence UF. And with that still highlighted in the content browser, I'm just going to jump back into the blueprint and click the little arrow here to make that connection. So it's now mapped into that instance slot. Pretty straightforward. So with that done, we can compile the blueprint and save it. We're all done with the blueprint now. So let's go ahead and just pull up that content browser one more time, and let's drag that blueprint out into our level. So there it is in our level, and you can see there's that little spline-based curve that's kind of on it there. I want to add in a few more control points on that. So if I just highlight that curve and hold down my Alt key, I can just start dragging out a few more points, and we're just going to get a fence that sort of shoots down the length of my treehouse here, maybe give it a little bit of movement on that, just something kind of like that, so it looks a little bit wavy as it shoots down in front of our house. So the next thing that we want to do is we want to start adding in information into that procedural content graph on how to work with this curve and generate some meshes or spawn some static meshes. So let's go ahead and load up that PCG graph by highlighting it and double clicking on it to get the editor up. And step one is getting information about this curve into the PCG graph. And that's really easy to do. If we right click on this and search for spline, we're going to get all the nodes that allow us to work with spline data. So what we want to use is the get spline data. Step one is getting that spline data into the graph. You'll notice that it's set to self. That's actually totally fine that it's referencing itself in this example, because in our blueprint, we've got the spline, we've got the PCG graph, it's all contained within that blueprint. So referencing itself is actually what we want to do in this particular example. So now that we've got that spline data in the graph, the next thing we want to do is we want to begin working with it. And let's go ahead and search out for those spline tools one more time. What we want to do is we want to sample that spline data, and we want to use that sampled data to create points that we're then going to spawn geometry from. So instead of using a mode of subdivision, which is kind of, the spacing down the curves here, we're going to set this to a fixed distance, a fixed increment distance. And now that that's done, we can go ahead and we can spawn a mesh. So if we do a static mesh spawner, very similar to what we did for the roof, we're going to want to define what type of spawning happens here. So we're going to leave it unweighted like we did for the roof. And I'm just going to come down to mesh entries and just click the plus sign to add an entry, go down to index 0, and we want to map something into this static mesh slot. Now, what we're going to map is actually some geometry that I downloaded from Quixel. So this is just a single chunk. This is actually how the fence came, where it's a post with 2 rails. And that's going to be what we're going to spawn or instance down that curve. So if we go back to our graph and bring up the content editor, you can see it's still highlighted in there. So all I have to do is click this little arrow button to map that into that static mesh slot. And there you go. You have a fence, but its spacing is a little off. So we're going to go back to the sampler. And in this sampler, we're going to crank that up to a value of something like 250 so that it looks a little bit better. And I need to offset this here. Middle point is where the pivot on that chunk is. So that's why it's sort of starting where it is. So that looks okay. Now, the thing that's kind of cool about this is, like, if I wanted to change the length or the shape or anything with this, it's now just a procedural tool, right? Like, I could move that point in, I could hold down my Alt key and add another point, add another, and we can use this stuff to kind of start to get these fences to do, exactly what you want. I just want to have it kind of round that corner nicely and wrap around my little treehouse there. So just like that, we've now built a nice spline distribution tool using a blueprint and a little bit of magic in the procedural graph network. Pretty straightforward. So the next thing that we want to do is we want to go ahead and actually I want to change this. I want to move this point out. I want it to be out here a little bit more like that. That looks better. The next thing that we're going to want to do is we're going to want to go ahead and add on some that moss that lives on the top of these this piece of geometry. So that's very similar to what we did with the roof. We want to sample this static mesh, this chunk of fence, and use that to create points that we can then spawn geometry from. So we're going to do the same thing we did for the roof, where we did a mesh sampler. And with that mesh sampler highlighted, if we look in our content browser, this modular chunk is still highlighted. So all we have to do is click that little map button, that little arrow button, to add that in. So that's going to be our chunk that we're going to sample. Now, we're going to use that copy points. Copy points you use all the time. We did this for the roof. So we're going to say copy points. So this is going to be our source. So we're going to get all the vertices, like this is set to be 1 point per triangle. And what we want to do is we want to have that happen for each individual chunk of fence that the spawner has spit down the length of that curve. So we're just going to take the output of that and shove it into the input of the target. So we've got something happening here. You don't know it yet because we're not displaying any of the debugging data. But as soon as we turn that on, you're going to see that we're going to have points going all the way across these fence chunks. So to turn debug on, you can right click on the node and just hit the debug box, or you can use the hotkey D. So as soon as we do that, you can see, okay, cool. there are all of my points that are being spit out. Awesome. And if I make changes to this mesh sampler, like instead of one per triangle, we do per vertex, you can see that distribution changes, right? Very, very straightforward. Now, I did mention the fact that there is the ability to view metadata that's happening throughout the graph down here in this bottom panel. And the way to do that, just to kind of give you guys a quick overview of that, is turn on the blueprint that we're using, or the graph that we want to visualize. And then on any of these nodes, if you right click on top of it, you can say inspect, or you can hit the A key. So if we inspect this node, you can see that it's got 7 points, and those 7 points all have positional data. So those are going to be my 7 chunks kind of shooting down the length of that curve. Now, if we were to inspect the spawner here, notice that the data changes a little bit. So the points are in the exact same spot, but the min and max bounds all changed, and we now have this new string added. So this kind of notion of seeing the metadata and inspecting the metadata really lets you understand kind of what's going on. It gives you this nice view. So if we inspect the data on the mesh sampler, you'll notice that we're getting 2,792 points, and they all have a density value of 1. By default, everything starts with a density value of 1. So that's how many triangles I have on each one of those chunks. So if I was to inspect this node, it's going to be a lot higher, because it's going to be basically the combination of all the points going down that length of that curve. So we briefly talked about density, and density is like one of the workhorses that you're going to use a lot when you're doing procedural content work. Basically, what density allows you to do is set grayscale values on all the points that exist in your network, and you can then filter that data to turn off or prune points out of the mix so that they are not contributing to the spawner, for instance. So that's exactly what we want to do. We want to basically take these points, and we want to get a grayscale value that represents the top of the pieces of geometry. We want to run some filtering operations on these guys to isolate the points that only exist on the top of our fence. So how do you do that? It's actually really pretty straightforward. Let's go ahead and turn off the inspector. What we're going to do is we're going to pull off of this guy, and we're going to do a normal to density. So when we do the normal to density, if we disable the debugger here and turn it on here, you can now see that we're getting grayscale values. So the kind of gray is a value of 1, and then black is a value of 0. So this is now driving that density value based on this vector, that normal vector that's been defined here. So what we want to do is we want to actually use this to essentially get rid of the points on the bottom part of the fence. So how do you do that? Well, that's just done with a simple filter. So if we search for filter, I've got to spell it correctly, you can see there is a density filter. So we run that density filter, and again, let's just debug that by isolating just this one node here. You can see that we're now only getting points on the very top of our fence chunks as they shoot down that curve, and you can adjust this to get more or less points based on, how many, the values where it's going to clip, essentially. So pretty straightforward. Now, in this example, I really want to have that moss be very, very dense. So having 1 point per triangle or 1 point per vertice is not enough points. So what we're going to do is we're going to go back to this mesh sampler. And in this mesh sampler, we're going to turn on voxelize. So this is using those geometry script nodes. That kind of voxelizer lives in the modeling tools. So if we turn on the voxelizer at a voxel size of 100, all of our points have gone away, right? Makes sense. If we put this down to something like, 10, some points are going to come back, but they're still really sparse. So if we go down to something like 5, we start to get this denser population. And if we go down to something really dense, like a value of 1, you can see now we have lots and lots of points that we can use to spawn out our meshes. But it's very, very uniform. Like, it's all the tops of those rails. I want to break this up a bit. So we're going to be using some noise parameters to do that. We're actually going to use a couple of noises to do that. So let's go ahead and go back to our copy points, and off of that copy points, I'm going to pull out another node. We're going to drop down a noise, and we're going to do a spatial noise. So the spatial noise is actually really pretty cool. It has a variety of different modes. We're going to leave it in this 2D mode, and let's just go ahead and look at the, let's highlight that guy, and let's visualize that. So right now, it doesn't look like much. And that's just because we need to change some of the parameters on this. So we're going to go ahead and make the contrast be something like 4. And then we're going to come down here and change the scale to be pretty big on that axis. And like, I don't know, 500 there, 500 there, and just maybe give it a little bit of, a little bit of rotation or something like that. So we now have this splotchy kind of noise that's going down and driving our density. So what we need to do is we need to combine these two together, the normal to density and the noise together. So how do you do that? Well, it's actually really easy. If you pull off of this guy and type multiply, we're going to get a multiply node. And the multiply node is, we'll pipe that in there. And by default, it's not going to work. It's going to give us this error, which is okay. The reason it's doing that is we haven't told it what we want to multiply together correctly. We actually want to multiply density for both the input for source 1 and for source 2. So by doing that, we can now visualize this by hitting the debugger on that guy. And there you can see our points are black on the bottom and this kind of splotchiness on the top. So if we run that through the density filter one more time, you can see now we have, these kind of splotchy little bits and bobs happening there. And, like I'm going to actually make this have a little bit more, a little more points in there than that. So something kind of like that. Now, the final thing that we're going to want to do is or actually not the final thing. The next thing that we're going to want to do is we're going to want to go ahead and we're going to want to spawn off of this some geometry. So let's just go ahead and do a static mesh spawner like we did before. And that static mesh spawner, we're going to actually do an entry. We'll do 2 this time. So we'll jump into index 0. We're going to add into this guy a moss. And we'll just grab moss 1. Boop, they're kind of big. We'll sort that out later. And then we'll go into number 2 here. Again, we're going to add in a moss, and we'll add in like moss 3. All right, so you can see it kind of changed there. So we have 2 different mosses. Now, what we want to do is we want these to be smaller, right? So to do that, we need to modify those attributes before they get to the spawner. And that's what we did with the roof. Same thing. So if we do a TR for this and then PO, we're going to do a transform points. So the transform points is going to let us essentially make these guys smaller. So we'll just map that into there. Pretty straightforward. Let's put this down to a value of 0.1 and put this to 0.15. And now we have a really nice moss patches, but they're very, they're a little too like on and off, right? So what I want to do is just add in another noise. So we'll just kind of pull this out here. We're going to add in one more noise, and this time we're going to do a spatial noise, or I'm sorry, an attribute noise. This is just like high frequency noise. And actually, if we were to hit E, we can turn off the evaluation of that node. And if we hit D on this guy, you can see that it's just high frequency noise everywhere. So what we want to do is instead of setting that to high frequency noise everywhere, we want to multiply that with its input. So it's going to come in now, and you can see it's just high frequency noise. It's going to kind of mixed in with that other input. So that's exactly what we want. Let's go ahead and just map that into that guy. And with that done, we can hit the E key, the hotkey, to turn that back on. And we might as well hit the D key to turn that off. And there you can see our noise that's kind of breaking that up a little bit more. And then, of course, if we wanted to see the effect of this, we can just hit E to enable and disable it. So if we turn it off, that's without the high frequency noise, and we turn it back on, that's actually with the high frequency noise. So that is that's basically how we can get Moss to exist on only the top side with a little bit of random breakup using a couple of noises. So the next thing that we're going to want to do is we're going to want to go ahead and make a slightly more complex modular version of this fence. All right, so we're going to use that same PCG network and blueprint that we set up for this simplified spline tool to generate the modular fence. So the idea behind the modular fence is instead of being one big chunk of the rail and the post, it's going to be all individual objects. So the post is an object and each rail is an object. The idea is you instance the post down the curve. That post will have sockets on it. Off of those sockets, we're going to spawn the rails that shoot down the length of the curve that create the fence rails. Now, the thing that we want to do is we actually want these posts to also be able to have random rotational values. So we're actually going to use a fourth piece of geometry, a dummy piece of geometry, to do the distribution of the rails. So let's go ahead and check out what this means. Essentially, I've broken this original one chunk into individual components. So we've got the post, and then we have the top rail and the bottom rail. So the idea is each one of these objects can have unique transform attributes assigned to them so that they breaks up and makes it look like a very random fence post. So the next thing we want to do, or the first thing we want to do, is we want to go ahead and we want to create that dummy piece of geometry. So in my origin, kind of over here, we're going to just kind of zoom in on this little fence post. It's kind of sitting over here. And what I want to do is I want to go ahead and create my helper object or my dummy object. So we're going to go to our modeling tools. In modeling, we're going to go and create a box. On that box, we're going to tell it to snap to the ground plane. We'll just kind of drop that down there and we'll just hit 0 and kind of get that guy at the origin. And then we'll make it have like, you know, something kind of like that. And then maybe make it 120 units tall. Okay, cool. So we'll accept that. That's going to be my dummy object. So if we have that guy, let's get rid of this one. We don't need it in there. If we have this guy and we hit Control B, we can change its name to something meaningful like dummy. And we can double click on its static mesh editor. And what we want to do is we want to add sockets on this. Those are going to be the points that we're going to spawn off those rails. So we're just going to say create a socket. We're going to give it a tag called rail. Just got to give it a name because this is going to be useful in the PCG network. And we're just going to kind of push that up and kind of push it back like that. I'm going to hold down my Alt key and add a second socket. So we've got socket 1, socket 2. They both have the tag of rail. We can save that out and we can jump back into our fence. So in our fence here, if we just kind of go back to where we were, ultimately what we want to do is we don't want to have all this moss in here and like right away. So we're gonna save that for later. We're gonna take all those nodes. We'll just hit C to put a comment on it. And we'll call it moss, and we're gonna slide this guy up and out of the way and just break that connection. So that moss is up there. What we want to do is we want to replace this static mesh instancer. Instead of using this big combined fence, what we want to do is we want to have it use that new dummy object. So we're instead of spawning off this guy, we're going to tell it to grab dummy. And just like that, you can see there's our post. Now, that original larger chunk, its pivot point was in the center. So we're going to need to offset this so that the pivot point will rotate around the middle of where those rails is going to be. And again, this is easy to do. We just want to modify that point data that the sampler is giving us to offset the dummy object further down the chain. So to do that, again, just search for transform points, add that transform points in there, break that connection, rewire it up, and the transform is going to get offset by like -150 or 130 or something like that. And that's going to essentially offset that guy so that it's sort of in the same spot now as our original larger fence that we had. So cool. The next thing that we want to do is we want to find those sockets and spawn off of those sockets those rails. So to do that, you're going to hit, all right, right click and search for socket, and nothing comes up. So that's a bit of a bummer. Here's the interesting thing. There actually is a socket tool. It's just not exposed to the UI by default. It lives in the sample plugins directory. So if you look at the execute blueprint and we drag this out, you can extend the functionality of PCG with blueprints, right? And if we look at this list of blueprints, a lot of the nodes that show up here in the left-hand side are actually just built up like copy points. Like tons of these nodes are actually just built up using simple blueprint logic. So if we search for socket here, you can see that even though it didn't show up in the UI, it actually does exist. So if we load that up and we double click on it, let's just check out what's going on with this guy. So essentially, we're kind of coming through, we're getting the sockets, we're turning those sockets into points, and then we're making those points into something that PCG understands. That's the easiest way to think of it, and that's all pretty cool. So let's go ahead and jump back into our fence, and if we actually hit the A key on this to evaluate what's going on with it. Right now, we don't have any static meshes added to it. So let's go ahead and put dummy in there. And we'll add that dummy in, and still there's no points in this data, right? Until we type in tag rail. As soon as we put in tag rail, you can see, oh my gosh, there's 2 indexes in there because we had 2 sockets on it. So that's our data for that one socket. So what do we want to do is we want to get that information for each one of these down the spline. So again, very similar to what we did before, we're going to use copy points. We drag out and do a copy points. That's going to be our source, and our target is going to be every single static mesh that's instanced down that curve, right? So if we grab that guy and shove it in there, now if we go ahead and hit the A key on this, you can see that's all of our sockets basically going down that spline, which is really, really cool. So now all we have to do is spawn out of the output of this a static mesh. So if we just do a static mesh spawner and click on that guy, and let's just go into this and give it a mesh entry and go to index 0, and let's just search for rail. We're just going to grab one of these because we're really tight for time. Oops, not that rail. Wrong one. Let's try that again. Let's grab that rail. All right, cool. So there they are. They're shooting down, and they're kind of doing their things. Now I'm going to actually go back into the dummy here, and I'm just going to offset these a little bit to kind of get them, a little bit closer to where I want. And I also want them to be further back a little bit. Like I wanted to have them overlap that fence ever so slightly. So you can see as I move these sockets, it's just updating, it's updating those rails that are shooting down that, which is super, super cool. So the next thing that we're going to do is just further refine this. The original chunk actually had a little bit of slope to those guys so that they kind of tucked underneath. So again, we want to modify these points before we get to the spawner. So to do that, we're going to drag out and just search for transform points and add that in. And with that done, let's go ahead and break this guy, drop that down there. And the first thing I'm going to do is I'm going to randomize the rotation around this axis so that each one of these is a different rotation, right? So that makes it look a little more random, like each one is going to get this random rotational value. And then we're just going to give this like a -3 to kind of give it a little bit of drop, and a maybe -2.5. So again, we're just trying to randomize stuff. Maybe put this to something like 0.3 on that guy. So now we've got a fence that looks kind of like that original chunk, but you'll notice that each one of these is got its own unique rotational value, which is exactly what we wanted. So the next thing that we're going to want to do is we're going to want to spawn meshes that are going to be, where those helper posts are. So if we go back into transform points off of the sampler, the same points we're going to grab, we're going to do another static mesh spawner. And on this guy, we're going to give it an entry of this. And if we just search for fence, we're going to grab that. And with that done, we can actually go back into this spawner, and we can hide it. Actually, I think I have to do visible. Let's do visible. Boop. All right, so there's our little fence posts. And again, like I said, we wanted those fence posts to all be random. Like right now, it's the same exact pattern going down that curve. So to do that, again, we're going to just use the same thing that we used before. We'll use transform point. So we'll just grab that, and we'll just hold down the control key to kind of map that in there, and what we're going to do on this one is change this to be not around that axis. I think this guy needs to be around Z. So let's just do random 360 around Z. So now you can see each one of these has, like a unique rotational value, and we're spawning off of those rails from that dummy geometry. So the next thing that we're going to do is let's go ahead and hook that moss back up. So if we kind of look over here, we've got this guy. And we're going to go ahead and just pipe that into, craziness. Pipe it into there. Now, this isn't going to look right. Like it's going to do something, but the reason it doesn't look right is because this guy right here, which is cool, we want this input to be the same input that's on the sampler, right? So let's go ahead and go back to this guy and just click that button to map that in there. And just like that, we now have our moss back on top of those rails. And even though they have random rotation, the moss only goes to that Y up vector based on all that logic that we built previously. So that is how I built up the modular fence. So let's go ahead and check out the finished result and walk you through a bit more of the other things that we're doing inside of this guy. All right, we are really quickly running out of time, so I've gone ahead and loaded up the PCG graph for the completed fence as well as enabled it in the viewport. And I'm going to walk you through the changes in the logic that are going on. And really the area where it adds complexity is the fact that we are using rail B and rail T for the rails that are getting spun off those sockets. So that creates a little bit of complexity because we're randomly choosing between rail B and rail T as it shoots down this length of the curve. So let's go ahead and look at the graph and I'll walk you through it. And like I said, a lot of it is very similar to what we've already built. So, this kind of spline sampler, all the same stuff. The static mesh spawner is going to be the helper static mesh spawner that's going to work with the sockets. So that guy is going to come up here and the sockets are going to be that same static mesh helper. And what we want to do is we want to get that that kind of data set of points that are going to have the sockets shooting down the curve for each one of our post helpers. And that's exactly what we get with the copy points. Now, where it gets a little bit different is we're taking those points and we're going to introduce into them a random value of density. So we're using this attribute noise to randomly set values between 0 and 1. And by setting random values on those socket points, it allows us to have two unique paths, one for rail B and one for rail T. And point filter is going to be our mechanism for defining that path. So what that means is on the point filter, we have an operator. So if it's greater than 0.5, it goes with the inside filter. If it's less than 0.5, it goes with the outside filter. So we have kind of, like two unique paths here. So if it's the inside filter, we're going to be using static mesh rail B. Static mesh rail B is kind of spawned off of that socket then, and we want to copy all the different points on that to create our moss and all of our little vegetation and things like that. So we're going to use our mesh sampler for rail B, just like we did before with the copy point. So it's going to copy that for every version of that rail B that's been generated down that path. So what that means is if we break this connection here, you can see half of my fence randomly disappears, right? Because that was all the areas that we're using rail B. So if we put that back on to complete that inside filter, we have the exact same thing happening for the outside filter, except it's using a different mesh. It's using rail T. Same thing for that sampling of that mesh down the length of the spline with the mesh sampler. It's also going to be using rail T. Now here's where it gets interesting. So we've got our two unique paths that we've got, our inside and our outside path. Ultimately, we want to create moss on both of those. So what we're going to do is we're going to merge those together. And if we just hit the debug on this, you can see that that's going to give me points that line up exactly with those pieces of geometry, right? Like the rail T, rail B, they're all exactly aligned as you would expect. And from that, then we can go back into running our moss logic, which is this is exactly what we built up before. So spatial noise, normal density, we're filtering stuff, we're introducing noise in, we're filtering it a bit more, and then we're going off and we're spawning all of our little pieces of moss that kind of go down each of those guys. So that is really the only difference is the level of complexity that we had because we have two different unique paths for those two unique pieces of geometry. Now, the other thing that we're doing that's kind of interesting is we're also spawning all these other little pieces of vegetation that drop, but they only drop close to the post. We're looking at the distance between the rails and the post, right? That's what we're using this distance node for. So we're comparing those two. So if we hit debug on this, you can see it's going to give me a gradient based on how close the posts are to the rails. And just like we did before, we then filter that information out. So if we debug that, you can see it's going to then now just give me a random set of, or not a random, but a more refined set of points on those rails close to that that post. And then ultimately what we're doing is we're adding in another normal, and then we're filtering that down to give me just a few little random points, if we kind of zoom in here, that only exist on those rails close to the posts on the top of the fence because we have that normal density. So the concepts are always the same. You're basically taking points, you're running noises into them, you're filtering them, you're trimming them down, you're putting more noises on them, and the end result gives you these very procedural kind of random looking graphs that do some really cool stuff. Now, there's one more thing that we're doing down here, and I'm using this PCG subgraph that's kind of coming off the same points that this little fence post is. And what that PCG subgraph does is it comes through, it introduces in some noise, it runs a random density filter to prune some of those out, and then it ultimately goes ahead and it spawns off this little piece of geometry, which is essentially these little twigs that kind of come here. So not every single post has those twigs, and if it does have the twigs, they're going to have a random rotation, kind of around their y-axis. So that's really all that we've done with this. We've added in a couple more pieces of geometry that are getting spawned off, but the big thing that's kind of happening here is the little logic to have the two different rails for our two different unique paths, and then the logic over here for the vine drops, which is using that distance node to only drop the vines sort of close to those posts. So I really hope that made sense. I know I was going super fast. I appreciate you all sticking with me. Thank you.